The diagram shows a solid prism A, B, C, D, E, F, G, H, and this has two parts. What is said in the first one, they are asking to find the surface area of the prism, and in the second part they are asking to calculate the size of the angle between AF and the plane ADEH. So let's try to find first the surface area, and I think this question carries 7 marks. This is a tricky question, by the way. You need to be able to visualize these 3D figures to work out the surface area. How many surfaces? Those are very fundamental things you should get to your mind. This is a 3D object and this has how many surfaces? 6 surfaces. Some of you, when you are calculating, you have found the correct surface area up to only 5 faces. You forgot some exist. Can't do that way, and you have to identify what are the matching faces also. And now you can clearly see most of the lengths are given to us. There are couples of faces, no? There is top, bottom, front, back, and 2 side faces. First, let's try to find the area of this front face, that is a trapezium face. So I'm going to find the area of ABCD, that is equal to what? You add the length of parallel sides, so 37 plus this length, it's also same as 21 here, GF length, so 28 divided by 2 into, what do we get, into perpendicular height. It is given, this 28 is given as what? It's not AB length, it's the perpendicular height. I think they are ADH and BCH perpendicular height is 20. 28 plus 37, we got 650 square centimeters. That will be the same as the area of GFEH or GHEF. That is the same area, EFGH area. We need to find the area of this part. I am going to find the side. To find side length, we need the CD or AB lengths. They will be same according to the way that the figure is given. So we are not given it straight away. We have to find it CD length. We are given this perpendicular height. Can we find it using that? They have given these side lengths equal. If I create two perpendiculars here, you can see this middle part, middle length should be equals to 28. No? 28. So this length, if I take this tiny little length as x, it's going to be equals to how much? That little x is equals to 37 minus 28, because there is also a little x part here, the same length, so it's going to be divided by 2. 37 minus 28, that tiny part is 4.5. And we know this height, it is going to be 20. Using these two tiny data, we can find the CD length, or we can use the Pythagoras theorem to find CD length. So CD squared is equals to x squared plus 20 squared. So CD length will be equals to 4.5 squared plus 20 squared, and then get the square root of it. I think we will be able to get a nice answer. What do we get? 20.5 centimeters. Nice answer, no? For CD. Now we can find the area very quickly. So CDEF area, that's a rectangular area, so it is equals to 20.5 length into breadth into 24. 492 square centimeters, and that is also going to be the same area of ABGH. That will be same also ABGH. Now we need top and bottom. Top area is equals to 28 into 24, 672. Bottom area is equals to 37 into 24. We got 888. We have everything to find the surface area. So total surface area equals to, we have the two trapezoidal faces. So this 650 into 2. Okay, two faces done. Keep in mind always we have to find all the six. And we have the side areas also same two rectangles 492 or so into 2 plus top and bottom. Top is 672 plus bottom 888. So addition of all these, how much? 3844 square centimeters. 3844 square centimeters. Little by little we can do it. No, this is not a very hard part. Only getting that CD length. You have to identify that CD length is straight away not given. You have to find it and take it. Now, how to do this part B? Part B. Let's try to quickly do it. Part B. Part B also. We don't have much time left. Now they are asking the angle between AF and this bottom plane. If I join this AF here, what do I get? I'm not sure it is making a good representation, so I'm going to this scene. This is really tricky. Okay, I use blue color here. Okay, now from AF I am going to make some other lines. Try to visualize this. If you see these triangles only, you can find this angle, because you have to make it simple. What you have to find, make it simple always. Make it always simple, otherwise it's really hard to identify what they are asking. So simply if you can visualize these lines, you will be able to find this angle. What they are asking, this angle. If I make this point here as I'll mark it as P, P, and this point as Q. We found QD actually earlier. This was our X, which is 4.5. Okay, what they are asking is this angle here, angle between this line P, AP and AF. This plane also stands for the same thing. So it's in the end it's going to be a 2D angle. We are not finding solid angles here, we are just finding the 2D angles. So this theta, they are asking this theta. How can we find this theta here? If we can find, now if you look at the triangle, I'm going to draw this triangle APF in here. A, P and F. If we can draw this APF triangle here, this will be my point A, F and P. Try to see it. I cut this in the middle, so this is theta. What I need to find, what I need is sum of these lengths. Easily you can find FP length. FP length is equal to this CQ length, same length. We already found this is CQ length or FP length is given, it is 20. No, this is 20. Already we know one length. If we can find which length, AP length, job is done. So if you look at this AP length, I am going to redraw the triangle of AQP. See, I am going to draw AQP again. See, this will be my AQP triangle. This is my AQP. These are in different planes. Please try to visualize. This is also right angle. This is also right angle. Okay. All these will be in different planes. One is in horizontal plane. This APQ. This is in horizontal plane, and the previous one I draw is in the vertical plane. Okay. Now this here. This is the triangle, and here also it is 90. Now this QP we know it is 24. AQ we can easily find 37 minus 4.5. So we can find AP length easily. So this is going to be 37 minus 4.5. How much is it? We got 32.5. 32.5. Now using Pythagoras theorem we can find AP. AP squared equals to this 24 squared plus 32.5 squared. So AP is equals to square root of this much. I'm going to get the answer 40.4 centimeters. Okay, I got this AP length here. See, this is the same length. This is equal to 40.4. Now using this triangle, I can easily find this theta, tan theta, no? Can get tan theta. Tan theta is equal to how much? Tan theta is equals to PF divided by AP. So it's going to be 20 divided by 40.4. So theta equals to tan inverse this amount, 20 divided by 40 over 40.4, 26.38 degrees. If you can imagine these triangles in this 3D world, 3D figure, job is done. So you have to identify if I can find this AP length, that's a right angle triangle. You have to visualize this, and what you have to find, the angle given is this theta. This plane ADEH means this line between AP and AF. You should be able to analyze the given data and simplify it. Otherwise, these kind of questions get a lot of time. They will waste a lot of time if you don't understand or visualize it properly.